Let's take a look at a few examples in which we're asked to find out if a shape is symmetrical, has at least one line of symmetry, or asymmetrical, no lines of symmetry. So in our first one, we have a trapezoid, and we are simply asked, is this trapezoid symmetrical or asymmetrical? So we just need to find out if there's even one line of symmetry. And if there is, it will be a symmetrical shape, and if not, it will be asymmetrical. So I look at my trapezoid and try to imagine putting a mirror up in different positions and seeing if the two sides of my line would be mirror images of each other. And sure enough, if I draw a line vertically down the center of this trapezoid, I can see that the two shapes on either side of my line are mirror images of each other. So this trapezoid is symmetrical. And since it's such a big word, instead of rewriting it, I will just put a square around it and say that that is my answer. This trapezoid is symmetrical. It has at least one line of symmetry. In our next example, we have a parallelogram. So the question is asking us, is this parallelogram symmetrical or asymmetrical? And what I've done in this case is I've drawn the same parallelogram 3 different times because we're going to take a look at what happens when we draw lines through the parallelogram and try to see if they're symmetrical. So I can begin by drawing a line down the center of my parallelogram vertically and try to see what would happen if I then take this shape and reflect it across the line this way. I would end up with kind of a shape like this coming over, which doesn't match my other shape. Similarly, if I took this side of the parallelogram and brought it over here and tried a fold in the paper, I would see that I would end up with a shape over here that looks something like, if this was my longer side here, it would come out longer here and shorter in there, and I would end up with not an image that's the same on both sides. When I reflect this across the center line, I see that it is not a line of symmetry. They are not two mirror images of each other reflected across the line. Similarly, I can draw a line through the center of my parallelogram horizontally and try again to see if this is a line of symmetry. And I end up seeing that it is not, because when I take my parallelogram and fold it down or reflect it across this line, and then I take the bottom part and reflect it up, I see that I end up with kind of a shape that ends up the opposite of this with some different shapes on each side, and it's not a line of symmetry. They're not mirror images of each other on either side of the line that passes horizontally through the parallelogram either. So far I do not have a line of symmetry. The vertical line through the center is not symmetrical, and the horizontal line through the center is not symmetrical either. And similarly again, as you might have guessed, if I draw a diagonal line through my parallelogram and try to fold my paper over and come this way, or try to see if I can come down and reflect this line over here, I end up with a shape that looks something like this and is not symmetrical. There's not mirror images of each other. And so, in the case of my parallelogram, this parallelogram is asymmetrical. I cannot find a line either vertically, horizontally, diagonally, or anywhere through the shape that would give me mirror images or reflections on each side of the line. So this answer here is the parallelogram is asymmetrical. My third question here is asking me how many lines of symmetry can be drawn through this hexagon. So I have a hexagon here, and I redrew it over here with a little bit of markings on it to help us see where the lines of symmetry are. So I can see right away that if I draw a line like we have been up here, vertically or horizontally, I will have lines of symmetry. But there's more than just those two in this shape. It turns out that in a hexagon, from each corner to its opposite corner, we'll find a line of symmetry. So from this corner to this corner is a line of symmetry, exactly the same, reflected on either side of my line. Same thing from this corner to this corner. There's a line of symmetry between the two shapes on either side of the line. And from this corner to this corner as well. Similarly, we can see too that if we draw lines from the center of one side across to the center of its opposite side, we also have a line of symmetry. We can do a line right here down the center, and we've got this shape matching this shape, mirror reflections. We can do a line of symmetry through here and through here as well. And in all those cases, we have a line going through with mirror images of the shape on either side of the line. So there's a total of 6 lines of symmetry in this hexagon. 3 of them go from one corner to the opposite corner, and 3 of them go from the middle of one side to the middle of the opposite side. So a hexagon has 6 lines of symmetry.